This is going back to the first presentation of today, which was about proxy outfiltering. I'm going to pick up from there and talk some more about protecting the infrastructure of the IXP, but from a different point of view or from slightly different needs. So I'll be mostly talking about packet filtering. And packet filters are important to handling all sorts of abuse and problems. Not everything that causes problems like this are actually abused. They could be just misconfiguration, such as the subnet mismatches that Stephen Bucker talked about this morning or earlier today. I've been running all sorts of services for a long time, close to 3 decades, that get DDoS. So I've learned all sorts of tricks about how to defend against them. And although the first thing you think about when talking about packet filters is layer 3 filtering, and also my first examples will be layer 3 filtering, the point is that you can do the filtering elsewhere on other layers as well. And basically my issue is that many of the hardware vendors don't have very flexible tools for what I want to do or how I want to do this. But because I represent a very small IXP, I alone cannot turn their heads. So basically what I'm here is to try to convince you, and maybe together, if we are all convinced, we can try to convince the vendors. So initially, for the first like 5 or 6 years, when I was on the internet, I used Cisco because there really wasn't a lot of alternatives back then. But then about at the turn of the century, Juniper came along. And then when I sort of had to transition to Juniper, I noticed that their approach to packet filters was a lot more powerful than Cisco's. Like they had named counters, they had rate limiters, you could share rate limiters between firewall rules, or you could have standalone rate limiters. You could build interface filters from multiple smaller pieces and so on. For example, as an example of this multiple segmented interface filters, at our exchange point, we have one packet filter clip for management functions, which includes rules for important things like ARPA, neighbor discovery, for SNMP if it's needed in the subnet, SSH or other control for management connections, and so on. Then we have another clip that allows everything that a web server needs. Then we have another clip that allows everything that a DNS server needs. And then we have a few clips that are very application specific. And then in each subnet, we add those clips into the interface filter of that subnet that are needed there. So for example, if we want to change something generic in the way we manage everything, then we can change just the management clip, which is shared with every interface, and then it will automatically be propagated to all the interfaces. Whereas if we just want to like add one more protocol to what is accepted from web servers, for example, then we add it there and it's automatically added to all the subnets where we have web servers. And now that I've been using Junipers for a couple of decades, I feel like I can no longer live without these features. So when I look at other vendors, when I want to buy new hardware, I feel vendor locked. So there are ways to do some of these things on other vendors, such as policy maps or route maps for packets or and so on. But they feel awkward, and I also feel that they are often inefficient, and they might still have some restrictions or limitations. So on to some examples. So IRC is probably the single service that I had to protect from DDoS the most back then. And so when we got the Juniper at the university where the IRC server was running, we realized that we can start making a lot more complex rules to protect the server and also to protect the rest of the network from things caused by the server. And so we started to develop this rule set piece by piece. So the easiest thing is that we can just accept everything that is actually needed by the IRC server to function, and then discard everything else. Of course, these examples that are on the right hand side of these slides are big simplifications. A real IRC server needs a lot more than just the IRC ports and the DNS port, because when a user connects to the IRC server probes the user's IP address and checks for all sorts of malware and proxies and stuff, because that's a big part of how abuse enters the network and the IRC network. And basically, those require a lot of different ports, a lot of different protocols. Of course, all of that needs to be also accepted by the firewall rule, or all those checks won't work. But then the bigger problem is that, that you discard everything other than what you need gets rid of a lot of the attacks, because a lot of the attacks are not directed at the specific ports that are actually in use. They just are so-called volumetric attacks. They just try to fill your pipe. So, so that helps part of the way. But then if the attackers switch to targeting the actual ports that are in production, that are actually being used, then it gets harder. And using a stateful firewall was right of the question back then, because a stateful firewall could maybe handle 10 megabits of traffic before it ran out of steam and then simply stopped forwarding traffic. And even these days, because now attacks are in the terabits, a stateful firewall is still out of the question. It will run out of states in a second, no matter how big it is. So one approach is to limit the traffic or the attack traffic to levels that the server or a stateful firewall can handle. So drop a lot of the excess, and then whatever remains, then you can handle and make more intelligent decisions on. So for example, here on the right-hand side, well, let's not go into the example yet. So basically what this can cause is that the attackers can achieve their attacking goals easier. The main goal for IRC servers was to just make the network split. So to make the connections between the IRC servers time out. That was the main goal often of the attacks. So basically, to protect against that threat, we needed to differentiate between the important connections, which were the server connections, and the less important connections like client connections. So in the example on the right-hand side, we first check if the packet belongs to inter-server connection, and then we accept it. And then the rest of the connections are IRC clients, and we also accept those, but we police them to 1 megabit because that is way more than what the server usually needs, more bandwidth than the server needs for IRC client connections. And once we started to add rules, that we also noticed that we should actually add a policer in every single rule that accepts packets. Have the bandwidth limit or packets per second limit high enough so that it should never be reached under normal conditions, but then in an attack, it has some filter or some limit for the traffic. And then we needed to go further. So the next step was, because TCP connections, IRC is mostly TCP based, and most of all the other protocols that are that probe the clients for malware are also TCP based. And TCP connections themselves are divided into stages, and the first stage, the connection setup stage, is often specifically attacked with a SYN flood. So one step to make the servers more resilient to DDoS attacks was to separate a policer for the SYN package or the TCP connection setup package with its own policer or rate limiter, and then the rest of the connections have their own policer. And also, since there are other connections like SSH has been used for management, and there are a lot of other protocols that are needed as well that are TCP based, we added a policer for all of those as well, because the attacker could potentially also use SSH SYNs to attack the server. Our management team for the IRC servers was spread around the world, so we couldn't easily limit the number of IP addresses where the SSH connections could come from in that case. So most of the attackers back then and still use off-the-shelf tools. So they just find scripts on well, in the worst case, they find them on some very well-known website. But then there are, of course, these shady websites that are less well-known where maybe you can find even better attack tools. But often they just use off-the-shelf tools. And they don't necessarily know what they're doing. They just launch the script and let it do its thing. And what that means is they often just target one or a few mechanisms, like just an ICMP flood or ICMP Smurf attack or UDP flood or TCP SYN flood or whatever. But it's only a subset of these attack mechanisms. And since we have separate rate limiters for every type of packet that the server is supposed to receive, then attacks like this only disable some functionality. Like, for example, if it's a SYN attack, SYN flood, new connections aren't possible, but all existing connections continue to function normally. And quite often, these cases are also very short. The attackers also often these days use services where $5 buys a 15-minute attack, and they often don't buy more than the 15-minute attack. So if our server can't accept new connections for 15 minutes, but everyone else is okay, then that doesn't really bother us much. Okay, let's go one layer down. So at the IXP, some IXPs do have layer 3 services as well, but many IXPs offload all the layer 3 services to web hosting sites or whatever, somebody else. But everyone has a layer 2 So everyone has the shared medium where the members' routers talk to each other. And we can start applying these same principles to creating a filter for the layer 2 filter. For example, our membership agreement very clearly states that on the peering LAN, on the peering B LAN, virtual LAN, you are allowed to talk IPv4, IPv6, and ARP. So we can accept those, and then when we can disregard everything else. And then we can also rate limit ARP as a simple measure because ARP itself is quite often the cause of, or ARP is the package seen most often in broadcast storms and stuff. So of course there are other measures to limit broadcast storms and stuff, but I believe in security by layers, so that if the other measures fail for some reason, then we have this measure as well. Or if this fails, then we have the other measures. And then we can go further. For example, our membership agreement also states that you are not allowed to use certain protocols like OSPF or Cisco Discovery Protocol or Link Layer Discovery Protocol or VRRP on the peering LAN. So we can just block those. And then BGP is here for a more interesting example. So basically, TTL security is a feature in BGP where at the IXP, members always send BGP packets with TTL value 255, so the maximum TTL value. And then they can filter incoming BGP packets where the TTL value is less than 255 because it didn't come from the IXP, it came from somewhere further away. So this is sort of link layer security for BGP, and many vendors implement it. There are variations in the implementation. But if we can build a layer 2 filter at the IXP at a very granular level, we can actually implement TTL security at the IXP. I'm not saying it's necessarily a good idea, but it's doable. And of course, the other feature here is RFC 8327, which is I don't remember the name of the RFC, but it basically it's for maintenance at the IXP. So if you are about to do some maintenance works on a switch, you can filter all BGP traffic at the IXP, and then all the BGP connections will die, and that will divert all the traffic, all the production traffic away from the IXP, and then you can do maintenance on the switch without any packets actually dropping, any production packets dropping, and so on. But since I'm told we're a bit over time, I'm going to skip ahead a bit. So basically, one idea for the other vendors would be to just adopt something that already exists, like Nftables. And there are some examples about that. You don't have to do it all in one go. And then there's another feature that some switch vendors that I run into with other switch vendors is that some switch vendors do not actually implement egress filtering, and this can make it very difficult to protect the control plane. But since I don't have time for the elaborate description of the attack, then maybe we'll leave this for another time. But so there have been 3 interesting talks today about features that IXPs need, like our proxy ARP connection, the BFD, and more powerful filtering. And basically, should we add these ideas to IXP switch or IXP equipment wish lists? And I don't know if we have time for questions, but thank you for the time.